Okay, I think that we can start. And thank you for everybody. Welcome. And this is our fourth session in the Living Lab. And just to we would like to start with a brief recap of what happened in the last week, and with our recap session for having an overall idea of what happened in the last in the previous session. So let me come back to the overall program of the Living Lab. That is split in 5 weeks. And let me also remark where all the material is available, our repository in the MedGold Living Lab webpage. And as you likely remind, in the first session, we have introduced the MedGold Living Lab. That is an end-on experience for development of climate service by using the methodological framework that we have also adopted in the MedGold project. Here we can see the 4 main steps of the methodological framework adopted in MedGold, and also used here as baseline for the Living Lab. The main objective of the Living Lab are understanding the basic steps for co-developing climate service, to understand the type of methods adopted in co-developing a climate service, and an update knowledge on where and how obtain climate data. In the first session, we have had an overall overview of the landscape at European level of climate service by Carlo Bontempo, the Chief of Copernicus Climate Change Service. And then our problem holders has presented specific problem for 3 sectors: wine, durum wheat and pasta, and coffee. And then we have left space for teams, because the teams are working hard in this week in self-organized meeting, and they are and today they have to show an intermediate presentation of what they have done during these weeks. And let me also finally remark the possible output from the teamworks. There are several possibilities. Writing a proposal on how to address the problem presented by the problem holders, or developing an application and code to do some analysis related to this problem, write a policy brief, write a strategic advice for the company, and or finally developing a communication strategy for company regarding the problem presented. In the second session, we have a look at the first step of the methodological framework. I would ask to all the people to mute their microphone, because we have some background noise. And in the first session, we have assessed the user needs of the users, and we understood how to assess it with the presentation by Marta Bruno Suarez from University of Leeds. In the third session, we have tackled with the second step of our methodological framework, the development service, and we have had several example good practice for climate service for agriculture, presented by Ronald Hoties from University of Wageningen, and then we have had some example from the MedGold experience, and an overall overview on how to access and use climate data to develop climate service, presented by Massimiliano Pasqui from CNR. Today we are in the third step of the test of the methodological framework, so testing the service. And in this part, we'll have a first presentation by Marta Terrado from BSc, and I'll briefly present her soon. And then we have a couple of presentations by Sandro Calmanti from Enea, from the MedGold coordination team, about the testing phase in MedGold. After the comfort break, we'll have some brief presentation by the three teams on the work planned and done, including the suggestion and feedback from the problem holders. Let me remind that the next week will be the last session with the final presentation of the work done by the student with the problem holders that should help us to evaluate to understand if this work could actually fulfill the request and the needs by the users. So I think that we can immediately go to the first presentation of today. The presentation is by Marta Terrado from BSc, and we are very happy to have Marta with us today. Marta has an experience of more than 10 years in agriculture, water management, and ecosystem service research. She is a science communication specialist at BSc in Barcelona in the Health Science department, and she supports the activities on communication, dissemination, and user engagement. She works in the co-production of climate service, and in this activity, Marta facilitates the transfer of knowledge for climate change adaptation at the science and stakeholders interface. She has a PhD in earth science at Barcelona and a master's degrees in geographical information system in the University of Catalonia. And if I could also add a few words, because she is a very proactive and enthusiastic member of the MedGold team. And finally, she was one of the first participants in the summer school that we have organized for a project before MedGold, Euporias, and so I'm very happy and glad to introduce to you Marta Terrado. Marta, let me know if you want to share your screen or if you prefer that I could share the slide for you.
Yeah, we can try that I share the screen, and then if I have any problem, I'll let you know. Let me see.
Okay.
So I take over
sorry, Marta.
Yeah.
Okay, sorry, Marta. Could you just speak just a little bit louder or closer to the microphone? Thank you.
Yeah. So is it better now or not? If not, I remove the headphones. Maybe it's better.
Okay. Thank you.
How is it now? Has it improved?
No, maybe no, but please come back to the first option. Okay.
Okay.
Okay, I will try to shout then.
Okay,
can you hear
thank
me?
You. Thank you. Yes.
Okay. So can you see my presentation now?
Yes.
Okay, so thank you, Alessandro, for the very nice introduction. And yeah, it's not necessary that I introduce myself because it has been done. So I'm going to start right away with the presentation. So I would like to start by using this slide. I'm sure all of you already know what climate services are, because this Living Lab is about climate services. But what I want to highlight in this slide is that the climate services community is all the time like working in this interface between the climate science community and then the stakeholders. And for that, this is not an easy task, because first, both communities speak different languages. They have different ways of understanding many things. So that's the real challenge of our work. So I am going to structure my presentation in 4 different parts. First, I will start by talking about terminology, which is what I have mentioned right now. But then I will also speak about visualization. Another point will be user experience, which is somehow close to the visualization of climate services. And finally, I will finish the presentation by giving you some examples of visual communication of uncertainty. So let's start first by the terminology. And I like a lot this image, because actually when inside the climate science community, we tend to think sometimes that everyone has the same way of understanding things, and that everyone has the same background knowledge as climate scientists have. So sometimes we forget that when we are using some vocabulary, some terminology, other people might get a different understanding of what we mean. So we need to be aware that more often than not, users are not climate experts. So to illustrate what I mean here, I will use the term uncertainty, which is actually one of the key points of my presentation. And when we talk about uncertainty, in the climate science community, we normally know what we mean. And if we go to the definition that the IPCC is providing for the word uncertainty, we can see that it's a state of incomplete knowledge that can result from a lack of information or from disagreement about what is known or even knowable. So there are like 2 different things here. First, lack of information, and then disagreement. These are like two key concepts in the definition. And then the definition goes on, and at the end it says uncertainty can therefore be represented by quantitative measures, for instance, the probability density function, or by qualitative statements, for instance, reflecting the judgment of a team of experts. And I'm sure if you have read some of the parts of the IPCC reports, you will come across some expressions like high confidence, low confidence, medium confidence, and this is very clear what it means for climate scientists. But again, it's still somehow vague. And actually, if we are a normal user, a lay person, and we look for the definition of uncertainty, for instance, this is a definition from the Collins Dictionary, you see here that the main definition is lack of certainty and doubt. So before we had lack of information, now we have lack of certainty. And before we had disagreement, meaning that, there are models that tell you one thing, other models that maybe tells you the opposite, but for users, it's doubt. So it's something that, you cannot take it so seriously because it's vague, it's not sure. So we need to pay attention at that, and sometimes make this extra effort to clarify what we mean. And this doesn't just apply to uncertainty. There are many other terms in the climate science field that have the same problem, let's say. So for instance, think of skill when we talk about accuracy or reliability. Now I will move to the second point of the presentation, which is visualization. And I will also talk a little bit about what we call the wow factor. So this is a bit like sometimes when we use visualizations, we use them to be more appealing. So we convey some climatic concepts, but in a nicer way, so that people are more willing to look at the information that is provided. So I'm going to use, in this example, I'm going to use the website Seasonal Hurricane Predictions, which is providing a prediction of the number of hurricanes that are going to occur in the next season. Actually, this one is for the current season because the hurricane season has started at the beginning of this month and it's going on until November. And as you can see on the web, on the homepage, there is very few information. We can find the number of hurricanes that are predicted to occur, and then the number of hurricanes that have occurred to date. So the prediction is 9 hurricanes, and to date we haven't had any hurricane yet. And then we have the symbol of the hurricane is in red, which means that this season is expecting a high activity in hurricanes. Then you can find other information on the homepage as well, like the historical average of hurricanes, and also the number of hurricanes that have occurred in previous years. And then for users that are more interested in having the details of the predictions, you can go to another plot on the website, which is displaying the prediction that each of the forecasters are giving. So on the homepage, you have like the average prediction of all forecasters, and then you can check, for instance, that NOAA has predicted between 6 and 10 hurricanes for this season. And then you can see a short explanation and the option to download the data used to do this plot. The main idea here that I want to tell you is that a climate service can be something as simple as just gathering different predictions from different forecasters and putting them together in a single platform. This doesn't have a high complexity. You might think, okay, you take a forecast and so on, but this is a service for someone. There are many users who are not going to make the effort to go to every forecaster's website, and sometimes the forecast is not even public either. So it's a good way to disseminate this type of information. And actually, as you can see, this is one article that appeared this month of May in the CNN, and it's entitled "Experts Agree This Hurricane Season Will Be Above Average, Maybe Even Extremely Active." And actually, for this article, they have used the plot that we have in the website of the hurricane seasonal predictions. But the only thing is that they have changed the plot. So what the author of this article did was to download data, and then he plotted himself, changing the colors, reducing the information provided in the axis, and so on. So by this simple interaction, what we learned was that first, that sometimes we have some assumptions that the way we plot, we display the information is the good one and is the nicest one and the right one, but it doesn't work for every user. So many users may want to adapt this, maybe to the format of the journal or whatever. And then also that it's very important to have this option of downloading data, because otherwise maybe this person would have gone to another website to get this information, or who knows. So, and now I'm going to move to the third part of the presentation, which is user experience. And it's very much connected to the previous one. But in this occasion, I will use another example. So the visualization that you can see now on the screen is a climate service that was developed under the Euporias project that Alessandro introduced at the beginning of my presentation, saying that I joined this summer school. So in the framework of this project, they developed different prototypes of climate services, and one was this one. And for this development, climate scientists work together with many other specialists. As you can see, this is not something that one climate scientist or a team of climate scientists could have developed by themselves. Here, there is also the experience of of communication specialists, of the data visualization specialists, designers, social scientists, and so on, that came together to think of the best way to represent this climate service. So what you can see on the screen are seasonal predictions of wind speed. The different lines that you see represent the prediction of the wind speed, but you have many different aspects. So, for instance, the scale is represented by luminity. So these lines that are like more shiny, let's say, are the ones that have more skill. And then in the areas where you don't see any lines, it means that the prediction has no skill. Then also the wind speed is represented by the width of the line. So thin lines mean that the wind speed, predicted wind speed, will be lower, and thicker lines represent higher wind speeds. And then the predicted change in the prediction is codified using two different ways, two different systems. So first color and then tilt. So this means that the lines that have blue colors and have the tilt going down, they represent that the wind speed in the next season will be lower than normal, and the yellow lines that the wind speed will be higher than normal. This was a prototype that was semi-operational, so it's not operational. And you can see that these predictions refer to the past. So they were for December 2015 to February 2016. And when the user is selecting one region in the map, then this lower panel opens, and one can find additional information. For instance, information on observations, also the value of skill, the install wind power when it applies, because also the wind turbines are represented. You cannot see them in this part of the map, but it depends on the region. There are wind turbines and also the install wind power. So, well, by this, I wanted to show you how important it is to have a nice visualization, because it's a kind of entry point to the user. So someone that sees something nicer would be more willing to use it. And even this visualization has won some awards in terms of design. So it won the Information is Beautiful Design Award. But having a nice visualization is not enough. So a very important aspect is that we need to ensure that this visualization is actually usable for the user, and more than that, easily usable by the user. So it's very important to have what we call user experience tests. So this means that we need to test that once we give the visualization to one user, this person is able to quickly understand the information that is provided. So that this means that he's able to look at the legend and then immediately process the type of information that you are providing and understand it. And then also what you normally do is give some tasks to the user. For instance, in this case, we were asking users to identify regions in the map where it would be suitable to install a new wind farm, for instance. So they had to think, okay, which are the characteristics that these regions need to have for me to put a wind farm there, and then somehow understand what each of the symbols, each of the glyphs on the map meant, and then spot this region. And then we conducted some tests to do that, and after the test we made the appropriate changes to the visualization in order to reduce the user cognitive load. What does it mean? Reducing the user cognitive load means that you try to make it easier for the user to use the tool, so that the person doesn't have to think that much or to go back to the legend all the time to make sure he understands or she understands the information. So we need to ensure that we make it as easy as possible. And what this allows us to do was to change a little bit this representation that was very nice and we were very proud about it, but actually it needed some fine-tuning. And what as you can see here, you can see the visualization with this design component, and then on the right another visualization that took into account this more user-centered design. And you can see that there are some characteristics like skill and intensity that were static in the first visualization, but now they are dynamic. So the user can filter the values of skill, the values of intensity, according to the threshold of interest for the decision at hand. And then also the predicted change was using 5 different categories in the original representation, and now it has been reduced to only 3 categories, because what we found out in the end is that users are mostly interested in knowing if one variable will be above or below the normal average the next season or the next decade, rather than more sophisticated delimitations like upper, mid lower. This is something that it's not that important, and on the top of that, it was very difficult to see the difference between upper and mid upper in the map. And now I'm gonna move now to more specific examples, because so far I have been giving you just some general ideas, which I think are nice, but it's good also to see some applications, and in particular for the field of agriculture, which is the one that it's so it's the focus of the Living Lab and of the MedGoal project as a whole. And to do that, I'm gonna present the visualizations developed in 3 different projects. And what I want to focus in these examples is how 2 different aspects are communicated. First, probability, and then skill in seasonal forecasts. So you will see examples of 3 different seasonal forecasts, and we are going to see how they codified it. So I'm going to start by a visualization, which is a decision support tool developed under the S2S4E project. This is a project about climate services for clean energy, and they developed this visualization, which is targeted to to energy users in general. And the visualization provides information on temperature, precipitation, wind speed, and so on, and also some other variables related to the energy sector. And but well, here what I want to focus in is that 3 terciles are used to represent the probabilities. So above normal, in this case, temperature, normal temperature, and below normal temperature. But what is interesting is that apart from the 3 terciles that you can see also in the map shows the most likely tercile. The user has the option to select the threshold of probability he's interested in, and then only the locations that have a probability in the most likely tercile that are over this threshold are represented. This can be useful for some users, and in this case it was. And then in terms of skill, in this case the ranked probability skill score is represented, and there is also one filter, so the user has the option to either to view all the predictions regardless of the skill, or to hide those forecasts that are below a certain threshold of skill. So there may be one user that is only interested in very high skill values, and then there is this option to filter. And because these particular users in the energy sector were very interested in the probability of extremes, we also displayed them in the map. Here you cannot see them because the option is not activated, but if you activate it, then you can see these triangles. What is interesting in this visualization is that they use what we call a progressive disclosure of information. What it means is that by default, the user can see a basic panel with general information. So when you click in a region on the map, this basic panel opens, and information like the probability of each tercile, the skill, which is called performance here because skill was not very intuitive for the users and they wanted to change the name. So basic information is displayed, but when a user wants to have additional information, there is also an advanced panel with information on the forecast trend, because in this case, sorry, I didn't mention it before, but 2 types of information is provided. So there are sub-seasonal predictions, which means predictions for the next weeks, and then seasonal predictions as well. So you are able to see all the range, and also there are in this panel you can find information on forecasts, past forecasts, observations, and so on. So why 2 panels? It's interesting to have both, because for less experienced users, seeing the whole panel with all this information can be scary and sometimes too overwhelming. So maybe if you are not very interested and you see that much information that you don't understand, you will stop using the service. But at the same time, there are users that are more experienced, that have a more technological background, and then it's good also to have this option for extended information. Now I'm going to move to another visualization that is developed in the BISCA project. This project is providing a climate service for the wine sector. And this is the visualization they have for the seasonal climate service. So here you can see seasonal predictions, in this case of monthly rain. And as before, they are also using terciles to display the information. But in this case, not only the most likely tercile is indicated by the 3 terciles, as you can see here, and also the probability of each tercile. And in terms of skill, well, not yet still. Okay, sorry. When they are presenting the probabilities, the prediction is used when there is a skill for the prediction. So you can see here there is one prediction, another prediction, but when there is no skill, the climatology is given instead. So here it's a mix of the prediction and the climatology. For instance, for the month of June, July, and August, you can see that the probability for the 3 terciles is the same. So this indicates that most likely this refers to climatology. And for the other months, because the prediction had skill, you can see that the probability for each tercile is different. And then to show the skill, also they are using the RPSS. But in this case, the value of skill appears when the user is hovering over the plots. Now you cannot see it because they provided me just with a screenshot, so it's not dynamic, but it's there. And in this case, they are not using a progressive disclosure of information, but they are providing all the information in the same panel, as you can see here. And this is because the users express their interest to have all the information in one single panel. That's why it's like that. It can be overwhelming, but it's the user request. So it's something that you need to accommodate if they want it this way. And finally, I'm going to move to the visualization developed under MedGold that I'm sure you have seen in previous sessions. So I'm going to be fast, but I want also to highlight these different aspects. As you know, it's a dashboard that is still under development, so it's not finished yet. But what you can see is that in this occasion, we are also using terciles. So what you can see in the map is the most likely tercile, either above normal, normal, or below normal. In this case, for monthly precipitation as well. And then in terms of skill, we are using a mask. This means that if the mask is off, it is not activated. What we can see is the prediction everywhere on the map. Regardless of if this prediction has a skill or not. But once you activate the mask, then the predictions that don't have skill are masked, so disappear, and you can only see the ones that have skill. And then there is, once you select a particular location, a lower panel opens. And you can find here information on the performance of the prediction in previous years. This is interesting to see because sometimes when you only see the value of skill, or you are told that the prediction has a skill or not, okay, you believe it. But sometimes for users, it is more intuitive to see what happened in the past, but looking at every year, but not focusing in a particular year. What I mean by that is that sometimes when you provide a prediction, the user will ask you, does that prediction work for last year, for instance? Meaning, did the most likely predicted tercile match the observation? And sometimes the answer is no, because for one particular year you can be wrong. You can just predict that something is going to happen. Like in 2018, the prediction said that the monthly precipitation would be above normal, but what actually happened was that it was below normal. And this is something that is negative. If you tell to the user, no, I predicted the opposite, it's not so you cannot expect that the user will trust the prediction. But what you need to have is an overview of what happened in the past, but looking at many years in the past, as many years as possible. And then you need to calculate how many times during these years the prediction, the predicted most likely tercile match the observations, and then compare it to how many times the climatology match the observations, so you can have an idea of which option is better. So, and I think this kind of representation somehow conveys this idea. And I will finish now my presentation by repeating just the 4 main messages that I wanted to tell to you. And the first one is that language matters. So it's important to use precise terminology and clear definitions. The second, that a nice visualization is a first step to encourage users' uptake, but it's not enough. You need to assess the user experience, interacting with the service and with the visualization. And finally, that being generic doesn't provide a useful service to anyone. So you need to tailor the climate information to each user and also to the particular application that the user wants to make of this information. And yeah, I finish my presentation here. I thank you for your attention, and and feel free to contact me if you want to discuss some of the ideas. Thanks.
Thank you very much, Marta. Very interesting, inspirational, and comprehensive presentation. Thank you very much. As you know, the presentation, Marta, will be available soon in the repository. And there is time for a couple of questions. And afterward, we can also write down your question in the chat, and then we can collect and pass the question to Marta in case. So time for question for Marta. And I have a question, Marta, for you, because so your presentation is is framed in the session of testing the service. In your experience, have you considered or used some kind of metrics to understand and test if the service or this kind of visualization that you have adopted could meet the needs and the expectation of users, and how?
If it could meet the what we have done to assess if the visualization was useful for the user, let's say, and understandable, is to conduct some tests in which we were giving some tasks to the user, and then the user had to perform this task, and then we were quantifying the performance by using quantitative and qualitative indicators. So quantitative means we were calculating the time spent doing the task using different visualizations. For instance, the two that I show you in my presentation, the project Tuco, which was very design based, and the other one, and comparing the time the user took to complete the task. Then also there were some users that were successful, other users that failed conducting the task, other users that give the task unfinished. So we calculated all these rates as well. And then, for instance, even we were like tracking, we were using an eye track, and we could count the number of times the user had to look at the legend again, and then after the legend, look at the map, and and the more times the user was looking at the legend, for us, it was an indication that the information was not clear enough. So these were like quantitative indicators, and then there were also qualitative indicators, like we were asking the user which visualization do you like the most, which one has been more easy for you, or even things like what you didn't understand. So many people were like, this thing with the opacity and shyness of to show the skill was not working for me, I couldn't make the difference, things like that. But this is more in terms of how you interact with the platform. Actually, I don't know if what you ask to me is more like if the platform was useful for the user to make a particular decision. We were using a decision, but it's true that maybe the task that we were asking the user, although it was based on the decisions that they are doing on a daily basis, it was not very complex. I mean, It was just in terms of looking for a region in the map and things like that. Okay, so other kinds of decisions could be also interesting for them.
No, thank you very much. No, Marta, you have completely and fully replied to my question. Thank you very much. I don't know if there are any other question. There are a question here in chat from Miriam, and I'm just reading the question. As there are plenty service providing seasonal prediction, for example, for the precipitation, how can we evaluate the reliability of each data? This is the question from Miriam.
Yeah, here, what do we mean by reliability here? I mean, so is it the definition? So what you are asking to me now is if we can trust these predictions. So how do we assess if we can trust them? Is more that? Or do you mean it in the sense of climate science? Yes. Okay. So yeah, one way we are using to see which prediction if you can trust the prediction or not, or if you have different predictions, which ones you can trust the most, is by looking at the skill. We recommend we recommend users to look at the skill of the prediction. So first, if the prediction doesn't have skill, we tend to recommend not to use it for decision making. So maybe the user can just take the climatology, so the average of what happened in the past. So imagine you want to know how the precipitation, you tell me now, yeah, it's gonna be in the next season. So just assume that it will be similar to what happened in the past if you don't have skill. But then you have skill and you have different predictions. I would go for the one that has more skill. Although, of course, there are different ways of calculating skill again. So you have different skill scores, and you have to pay attention to that as well. You know, when you calculate the skill, scientists are not always doing it the same way. They can use the RPSS that I showed to you, or they can use other scores. And you have to be aware that some scores take into account just the hit rate, so how many times you are successful when you are making a prediction. But other skill scores, sometimes they are penalizing you if, for instance, you predict your season to be higher than normal, and then what really happens is that your precipitation is in the normal. This is one thing. But then you can predict also that it's higher than normal, but your precipitation can actually be below normal. So there are some skill scores that penalize you more the farther away the observation is from the prediction that you had. So there are other things that you have to take into account as well. So also look at which kind of metrics these predictions are providing for skill.
Thank you very much, Marta, and thank you again for your availability. If you have any other question, please write in the chat, and then we can pass the question to Marta. And it's time to go to the next presentation. Next presentation is some example of testing the service in MedGold. I would like to thank again Marta, and bye Marta, thank you. And now it's a pleasure for me to introduce Sandro. And Sandro is one of the member of the MedGold coordination team. He's a climatologist, and he works in an air for sure. And now his presentation is on the quality assessment on the MedGold service. So I'm very glad to leave the floor to Sandro.
Thank you, Alessandro. So actually, my contribution today is split in two. And one is, the first part is on the quality assessment, and the second part is on the testing. Actually, what I will be doing is to share with you all some of the experiences of MedGold in developing climate services, and so this is really, since MedGold is an ongoing project, this is really an occasion for steering some discussion. So what I will be presenting today is our personal experience as a project and propose some issues for discussion. So let's start with the quality, with the issue of the quality assessment. The first thing that we need to have in this case is a proper definition of quality. And this is not easy. So it's not easy and it's not obvious. And to frame better the discussion, we need two different components. First, to understand what is the nature of the services that we are trying to develop as climate services, and then from there try to derive what is a good definition of quality. So the objective here will be really to understand what a good and also an operational definition of quality might be. So you can look at Met Gold as kind of an intersection of two different types of activities. Some activities which you can see here sort of in the vertical direction are associated to each of the different sectors that Met Gold is targeting. And so Met Gold is developing services for different for each sector, for grapes, wine, olives, durum, wheat. And in each sector, what we are trying to do is to either develop new tools which support decisions or which creates new opportunity to access data or do some operation, but also another component of the activity is to also upgrade existing tools in each sector. So, and these are the activities that in this diagram here go in the vertical direction. And then we have on the horizontal direction some cross-sectoral activities that enable the services in all of the sectors. So, for example, from this point of view, we have been working a lot on the development of an ICT platform that provides different services, from access to data, to processing and transformation of data, to the visualization of data. But also we have done a lot of work, we are doing a lot of work on engaging with the sectoral communities. And this is really one of the key aspects and key components of the development of a climate service. So to understand better what concepts are relevant for the quality of climate services, it's really important to understand what is the nature of these services that we are to build. To start with, I would like to make a comparison with what is usually understood as a meteorological service, because this is a concept which is more common for all of us. And so in general, a weather forecast, a weather service is based on a definition of this kind, which is so the key ingredient of a weather service is a precise indication of the type of expected events in particular locations. So a very large component of the quality of a weather service is really the quality of the prediction. And of course, there can be errors and there can be uncertainty also in this case for the predictions in the short term for weather services. And a large part of the quality is associated to this aspect, to the quality of information. Then, of course, there is the accessibility, the timeliness, but in this case, a large share is associated to the quality, and probably a user will run away immediately from a service which doesn't provide a weather forecast which is accurate. For weather services, to explain a bit more what a weather service, a climate service looks like, and you have already seen a lot of examples from Marta. I have used this this picture, which is probably familiar to many of you, or to all of you. And so here, the first, I will have a question, in fact, for you. Is there anyone here, like in the room, that hasn't seen this picture before, or has a question on this picture? Do everyone knows? Does everyone know what this figure represents? Okay, I'm not getting any questions, so I can assume that everyone knows what we're talking about. In this case, what I would like you to focus on is two aspects. So first is sorry, the horizontal time axis. And here we can see two things. One, that the time axis is spanning across different time scales and across a long period of time, from the past to the future. And this is a common characteristics of climate services in general. So there are different time horizons, there are different time scales that are that can be of interest for users, for different users, and that essentially contribute and make the basis for a climate service. And then there is another aspect, which is this shaded colored areas. And this is something that Marta was already mentioning several times, and it's the uncertainty. And the uncertainty is also associated to, of course, the risk of, given the fact that there is uncertainty in the information, this is also associated with the fact that users are facing a risk in using the information to take their decisions. And this is something that happens every time. People make decisions based on uncertainty in every condition. And what we do here is that climate science in general has a lot of information that can help in improving decisions, but we need now to understand in what conditions this information has possessed the right quality, so that we can say that a climate service is of good quality or not. So what I will do in the next slides, I will list some of the characteristics that according to our experience, our direct experience, a climate service should possess in order to be defined of good quality. And we will see three different dimensions. Let's start with the first one, relevance. Of course, a quality climate service should be based on accurate data. This is to some extent similar to what happens with weather services, because of course climate predictions and climate data should be tested and always tested, and the quality assessment of data is a fundamental component of climate services. But there is also an additional aspect here, which is that usually the use of socioeconomic data and also other non-climate information are very much important for the development of climate services. And of course, the concept of accuracy of input data applies also to this aspect. And we are seeing, for example, this type of concept also in one of our activities in the Living Lab. Second aspect that is important for relevance is that climate services are always very much tailored to the specific needs of users. And this is really important because especially in the area of climate services, users provide real input to the service itself, either in terms of data, or in terms of knowledge, or in terms of technology. And most of the time, developing a climate service is also about understanding what is the technology which is already adopted by users, and creating interfaces to this technology. Most often, for example, when this is about when climate service is about, for example, providing data and provide tailored data for some downstream use of different kind. And this is something that, for example, we are doing in MedGold, where one of our application is about providing seasonal forecast data for a crop modeling platform. Third component, which is also very important, is that a quality climate service should be relevant for the geographical location of the users. This is very important. The use of high-resolution data and the objective of providing geographically accurate resolution is a very important aspect of climate services, because users require that information is relevant to their specific sites. And this is a request that comes everywhere, and is also quite obvious, because I want to, even if from the climate science perspective, we, and I include myself into this, we sometimes tend to underestimate this aspect of the quality of climate services, because we know that climate processes very often imply modification of processes that occur on very large spatial scale. But what users are really interested in is what happened above their head. And this is, of course, something that one needs to take into account when one wants to turn science into service and into a product. Second aspect, which is relevant to the quality of a climate service, is its usability. We have heard a lot about this from Marta. And here I want to specify some more in terms of, for example, what we mean by a usability of information. Of course, it must be easily accessible, because users are not climate scientists, and they are concerned with different problems than, for example, accessing data or understanding what a plot exactly means. The information must be there and must be clear. The information must be actionable. So real decisions should be enabled by the service. This might sound obvious, but we also encountered during the project McGold in some situations where users said, in this situation, maybe I know that some colder than usual situation is coming, but I cannot actually do anything about that. So this is not really a useful information to provide, even if, in principle, it will be possible to provide that kind of information based on the data. So from this point of view, the establishing a link between actual decisions and the information which is provided and the data which is behind the information is really important. And this is something that was at the base of MedGold since the beginning. And then, of course, information should be consistent with the background knowledge of the users. And Marta, for example, before has provided a nice example of what I mean here. Sometimes terminologies are different, and it's difficult to understand each other. So it is very important that whatever is done is consistent with what is the understanding and the background knowledge of the users. And it is also important, when there is an opportunity, to work on climate services by expanding, by enhancing the capacity of tools that users are already familiar with. And on this, we have a couple of examples in MedGold, where the service that we are providing is not actually something new, like the dashboard, for example, that you have seen before, that we are developing in MedGold. In that case, this is something completely new. But In other situations, we are also helping and supporting companies in expanding the capacity of the services that they are already providing. The third dimension is the value. And this has two aspects. On one side, the climate service comes with a cost, of course, and this should be affordable. And this is very important in the case of climate services, because climate information is usually just one among many other factors that contribute to how users make their decisions. So the value of climate information in some cases might be marginal. And so in this case, this means that, for example, the willingness to pay for a service should be taken into account, and the cost of the service needs to match with this willingness to pay, and this is a very important component. And this is, of course, also part of becomes part of the quality. And as a last component, since in the end climate services are a tool to increase the resilience of productive activities in general, it should always be very clear in which way climate services avoid losses, or in which way they reduces the costs for the users, or in which way they increase the income. So this should always come as a very clear component of the climate services, and this can contribute to the quality. To conclude with this part, this is what we can propose and what we can think of when we think of the definition of quality for climate services. Is the overlap of different components. The relevance on one side, the usability of the service, and also there must be a clear understanding of how the climate service creates value for the user. So now that we have a definition of the quality, I would also like to share with you some of the experience that we did in terms of testing the development of the services. But before going into this, maybe I would leave time and for, I don't know, some questions, discussion, maybe some ideas from you.
Thanks, Sandro. And are there any questions for this part of the presentation of Sandro?
Mm-hmm.
If it's not the case, I think that Sandro, you could go ahead, and then we can collect all the questions at the end.
Okay. So second part, it's about the testing, and in this case, I would like to give you a real a direct experience, an account of the direct experience that we did in MedGold, and really describe the testing as an iterative process, just as Marta Bruno Suarez was describing during our first session. So in this sense, I would like to really give you the feeling that the testing of climate services is not something like you are closed in your room, you do your work, and then deploy something and test if it works or not. But you really need to engage into this iterative process in which you test things and correct your process. Just because, and this happens just because the perspective and the contribution of the users of climate services are so relevant in the not only in the development, but also in the operations of the services themselves. To go back to what was the overall structure of MedGold, to describe this iterative process of testing, I will focus on the cross-sectoral activity of developing the ICT platform, because this is the activity that, of course, in MedGold played a quite relevant role, because it spanned across all the sectors. So we start from step zero, just design a concept of what the ICT platform would look like. And this is very interesting because, and also curious, because when we started with MedGold, we actually thought that there might be some ICT platform behind, so some information communication technology functions that should enable the services that we wanted to develop, but we didn't know exactly what this ICT platform should contain or how it would look like. So it was to us also, even to us, a sort of an empty box. We knew that there should be something, but we didn't know exactly what. What were the main components that we would expect to make this ICT platform? What was the main functionalities? We made some hypotheses, and this was the first step of testing. We have discussed the concept with the users in all sectors during a first round of meetings, workshops, focus groups. And so after this first phase of testing, we came out with some very high-level functional requirements. So we started at this level to really start to understand what was the request, what were the requests in terms of accessing the data, what were the main aspects in terms of processing and computing the data, and also what were the main requests in terms of output of the climate service. In some situations, the request was about visualizing the data, and in some other cases, the requested service was to access data, to process the data, and to make them ready to do some other calculation. So really a diversity of different services that then this ICT platform should enable. So the second level of testing was to look at this high-level requirement and discuss them further with users. So, for example, and this produced two different types of output. One was, for example, the functional specifications that then provided the input for the development of the dashboard. So at this point, the testing was not on the general requirement, but we went a bit more in the detail and try to understand in a more specific way how to visualize the data, what were the main component, and this produced then the output that Marta has already shown before. So and then of course this led to the third phase of testing. After the first raw visualization platform was implemented, we started all this process of co-developing and incrementally testing the implementation of the visualization platform. And I have to say that this was a very interesting process where users were really engaged in providing real-time feedbacks on what aspects of the visualization dashboard should be improved, what colors to use, how to place the button on the dashboard, for example. So really an iterative process that lasted for a few months and that led us to develop the visualization dashboard in the way as it is today. But as I said before, the ICT platform which MedGold is developing is not only about visualizing the data, but is also about retrieving, processing, and preparing data for other applications. And so this is also going to through a process of incremental testing where we prepare some of the data, see how them work, check with the users of the data and of the output if the system is working correctly, if the interface if the data interface is appropriate. And this is a process where you most likely make a lot of mistakes and incrementally adjust and come out with a more clear flow chart, for example, as it is represented here, that, for example, in this case, brings data which are retrieved from the Copernicus Climate Data Store to through a whole chain of processing, bias correction, downscaling of the data. We have mentioned before how important this is to bring the data to be relevant to the users, and then all the way down to the output, which in this case is not a visualization platform, but it's data which is then used by the users to do some other computation. And of course, there are a number of questions that comes into this. So, of course, there is a question if really this all processing is providing the data which are required, how stable the system is. Because if you think that there is someone that needs to use this chain of processing to in turn deliver another service, there is also an issue of stability of the entire process. There is an issue of scalability and replicability in case someone else wants to use this same type of processing. And then we get to the next step of the testing, which is, of course, the evaluation and the valuation. So where does exactly the climate service create value for the users? And also, of course, there is an issue of exploitation. How can we, for example, bring all the developments to something which is which can live on its own, for example, on a commercial basis, so that companies can use the technology to sell their services. And this will be actually the subject that will be discussed during the next session next week. But really what I wanted to give you the impression of is really how this concept of testing in the case of the development of climate services is really an iterative process in which things are always improved, and especially at this stage of the overall, let's say, even to some extent, historical stage of development of climate services, which is anyway in any way something which is new and on which much technological and also conceptual improvements, different ways of using information and also perceiving information are being developed. This iterative testing process is really important and is really a key aspect of the development of climate services. I've also left a bit of bibliography references that you can look at, and I will leave the this presentation on the Living Lab repositories, so you can find it there. So thank you very much, and well, most importantly, I would like to have a feedback from you and see if all these discussions can be interesting for your activities during the Living Lab and beyond.
Thanks a lot, Sandro. Very, at least in my opinion, very useful presentation and plenty of useful suggestion and idea. We have some time for question for Sandro. For sure, Sandro will be available for replying your question even after. But if you have some question ready, there is time for some question before the comfort break.
Mm-hmm. Mm-hmm.
Don't be shy with Sandro. Okay.
Mm-hmm.
Okay.
Maybe a tiny question. Thank you, Sandro. This is Raed. I definitely, thanks a lot for the presentation. I see indeed that there is a lot of value to think every step in details while building a climate service, and that's quite a detailed process. I think we are challenged in trying to do something similar as a mock-up tool in a short time, and I really see the need of time, as you said, that each step actually is quite complex, and then there's feedback needed, and a lot of difficulties might arise. So I wanted to ask you what surprised you as a step that really took much longer than what you had initially planned while building this service?
Well, there are a lot of surprises. There have been a lot of surprises during MedGold. Well, so certainly the design development of the visualization strategy is something that, I mean, it didn't came as a surprise because we knew already from previous experiences that this would have been an important component, but this was certainly one of the challenges that we had to take. One of the another well, let's call it surprise. You see, I'm hesitating in calling them surprises because to some extent I was expecting all of this. But let's say that you always find new, interesting things to cope with. It's also this issue about the terminology. So at which, for example, in the specific case of MedGold, where at some point, actually very early in the process, ended up in having the problem of defining what do we mean as reliability of data. And we very soon recognized that users and providers of information in this context, so climate scientists on one side and users of climate information on the other side have a very different understanding of reliability and of skill of the information. And this is probably this is actually quite obviously linked to the fact that climate scientists usually look at the issue of the reliability in terms of the consistency of the information with the knowledge which is behind the information. And so they tend to consider reliable something which is consistent and up to date with the best knowledge that everyone has, while of course users look at the value that the information creates. And so matching between these two aspects is probably one of the surprises, let's say, and in this sense, maybe not a surprise in the sense that it was something unexpected, but maybe a surprise in terms of understanding how much do we still have to learn in this field. And I tend to I tend to consider now that even at the end of the project, the concept of reliability will still be something that we will need to work on for some time. In this sense, this was a surprise.
Okay, thanks a lot.
Thank you, Sandro. Thank you, Rahed. And I don't know if there are any other questions for Sandro, but I think it's time for a comfort break. And so if there is a quick question, we could. It's not seem the case. So I think that we could have the comfort break now. Now we can reconvene in 5 minutes. And so at 12:42 to 12:40 in 5 minutes since now, and we'll come back with presentation by the three teams about the work they have done in this week. So have a good comfort break, time for coffee or whatever you want. Talk to you later.